Okay, we welcome back to our class on three-dimensional force analysis. As far as the previous recordings are concerned, previous videos are concerned, in the previous recordings we tried to explain how we analyze a particle for its equilibrium in three dimensions. Let's solve a few more problems. The question that we have is about, again, the crate. Determine the maximum weight of the crate so that the tension developed in any cable does not exceed 450 pounds. So we have a crate whose weight is not given to us, and this crate is being suspended from three cables, AB, AC, and AD, and the arrangement of these cables is given to us. We have a condition that the force developed in each of the cable should not exceed 450 pounds. How much is the weight of this crate? In order to solve these types of questions, again, we use the previous procedures. First of all, we will write down the coordinates of different points in space. So we have, first of all, point B. As far as the coordinates of point B are concerned, along x-axis, the point B is at -2, so -2 feet. So we'll write this is -2. Along y-axis, the point B is at 1 feet, so this is +1. And along z-axis, the point B is at 2 feet, positive. These are the coordinates of point B. As far as the coordinates of point C are concerned, the coordinates of point C are along x-axis. Along x-axis, this point B is, in order to reach to the point B along x-axis, we have to move 2 feet, but in -x-axis, so this is -2. Along x-axis, along y-axis, it's again -2 along x-axis, because the point B is coordinate along y-axis is -2, and along z-axis it's 1 feet. Okay, so these are the coordinates of point C. Okay, now as far as the forces are concerned, the weight of the crate will be acting downwards, so we'll represent this by, this is W. So we'll be having tension in the chord AD, so we'll write this as FAD. So this is our FAD. We will be having tension in the chord AC, we'll be calling that as FAC, and we have the tension in the chord AB, and we'll be calling that as FAB. So tension in the chord AB, we must be calling as FAB. So these are the three forces that are acting at point A, and we have to calculate the equilibrium based on, we have to write the equilibrium equation based on these forces. We know the equilibrium equation says that summation of all the forces should be equal to 0. The vector summation of all the forces should be equal to 0. And we are measuring this equilibrium at point A. So summation of all forces at point A should be equal to 0, which implies that we have FAD. For first force we have is FAD. Its vector summation with FAC, FAC, FAD, FAC plus FAB plus FAB and this fourth force is W. Their vector summation should be equal to 0. This is the condition that we have in hand. Now, as far as this FAD is concerned, we can write this FAD as, in terms of its magnitude, the magnitude of FAD is FAD itself, and the direction is it's acting along, we're assuming it to be acting along x-axis, so it will be I cap, FAD, I cap, plus we have FAC. So magnitude FAC and unit vector drawn from A to C, the unit vector drawn from A to C will be -2, the coordinates of point A are 0, 0, 0. So it will be -2, -0, I cap, -2, -0, J cap, 1, -0, K cap divided by the magnitude. So we can directly write that as, it will be -2 I cap, -2 J cap, plus K cap. And the magnitude of this divided by the magnitude, that's equal to -2 square -2 square plus -2 square plus 1 square. This is the unit vector. Okay, similarly we will talk about this. So we have written FAD, we have written FAC. Now what about FAB? So again FAB we can write as magnitude FAB. So that is FAB, and unit vector drawn from A to B can be written as -2. From A to B we are writing the unit vector, so it will be -2 I cap, -2 I cap plus j cap plus 2k cap divided by the magnitude, that is -2 square plus 1 square plus 2 square. This is it. Okay, so this is our FAB plus W is acting along minus, so it will be uh, it's acting, it will be minus W k cap. The vector summation of all these should be equal 0. So we can solve this as, this is, write down I components on one side, so we can write FAD. So we have FAD. Now we have -2 divided by this edge FAC, that will also be along I, so it will be minus FAC. So we have to solve 2 divided by under root of 2 square plus 2 square plus 2 square. This is 4 plus 4 is 8, 8 plus 1 is 9, so this is 3. So we will be directly writing it is 0.66. So it will be minus 0.66 minus 0.66 FAC. So these are I cap components we are writing first, and we have this FAB, its I component is 2 divided by this much. So this is again 2 by 3, so this is minus 0.66 minus 0.66 FAB, minus 0.66 FAB, and these components are I components. So we'll write this as, this is I cap plus, then we will write the J components. As far as the J components are concerned, this force does not have a J component. So we'll simply, as well as we're having this, we're having this component, this acting along Z, it does not have any X and Y component. So now compiling these J components. So first we'll be having this component. It will be again, this is -2 divided by 3, that is minus 0.66 minus 0.66 FAC minus 0.66 FAC. This will be the first component, and we are having again, this is this is FABJ component, so it is 1 divided by 3, that will be plus 0.33 FAB, 0.33 FAB, and these components are acting along J cap, so we'll write this as J cap. And the last one we have, so plus the last component we have along K cap, so it is, this component of FAC is along K, so it will be 1 divided by this much, that is 3, that is 0.33, that is 0.33 FAC, and we have this component along this, that is 2 divided by 3, that's equal plus 0.66. I'm writing up to 2 decimal places only, 0.66 FAB, 0.66 FAB, and we are having the last component, that is minus W, and these forces are acting along Z axis. So we'll write this as K cap, this has to be equal to 0. Okay, now since this is a 0 vector, its X, Y and Z components are 0. So if you see on the left, when two vectors are equal, then the left hand side and right hand side components have to be equal. So if you have X component on the right hand side is 0, then X component on the left hand side has to be equal to 0. Therefore we can write what we have. Therefore we have FAD minus 0.66 FAC minus 0.66 FAC minus 0.66 FAB should be equal to 0. 0.66 FAB is equal to 0, and we have this condition as well, that is minus 0.66 minus 0.66 FAC minus 0.66 FAC plus 0.33 FAB 0.33 FAB should be equal to 0. These are J components. And the third one is 0.33 FAC, 0.33 FAC, 0.33 FAC plus 0.66 FAB minus W is equal to 0. So these are the three equations we are obtaining. Now you see in these three equations we have four variables. We need to find FAD, this is one. We need to find FAC, that is second. We need to find FAB, this is third. And we need to find this W, this is the fourth variable we have, but we are having only three equations, okay? But we are given that the force in each of these cords should not exceed 450 pounds. That force FAD should not be 450 pounds. It should not be more than 450 pounds. FAC should not be more than 450 pounds, and FAB should also not be equal to 450 pounds. So what we do is, first of all, let's assume that FAD is equal to 450 pounds. Let's put FAD equal to 450 pounds. Let's make a trial and see what we will obtain. Okay, because we know the restriction that we have been, that has been imposed over this system is that the force should not exceed 450 pounds in any of the cable. So let's take case one, where we say, I write here, let's take this as case one. Let's say this is case one. And in this case one, we say FAD is equal to 450 pounds. If FAD is equal to 450 pounds, substitute the value of FAD in this equation, 450. Then we are FAC, FAB, FAC and FAB. From these two equations, we will obtain the value of FAC and FAB. Okay. So once we obtain the value of FAC and FAB from these two equations, we will substitute FAC and FAB values here and obtain the value of W. Okay. So for FAD equal to 450 pounds, so if we substitute the value of FAD equal to 450 pounds, so the equation that we have, this equation reduces to minus 0.66 FAC minus 0.66 FAB becomes equal to, this to take on the right hand side, this will become equal to minus 450. So this will be minus 450 pounds. Okay. So now let's do one thing. Let's solve these two equations to obtain the value of FAC and FAB. Now, as we have assumed that FAD is equal to 450 pounds, okay, and now we have these two equations, FAC and FAB. Okay, we will be solving these two equations. So as we solve these two equations for FAC and FAB, from these two equations, as you will solve them, you will obtain the value of FAB becomes equal to, the value of FAB comes out equal to 454 pounds. 454 pounds. Okay, so we have assumed FAD equal to 450 pounds. We have substituted the value of FAD in this equation. Now we are using these two equations to find FAC and FAB. So as we are solving these two equations by elimination method or any other method which you are familiar with, so we are obtaining the value of FAB coming out equal to 454 pounds. But this is not possible because it is violating our condition 450 pounds. That force in each of the cables should not exceed how much? 450 pounds. So when we are assuming for FAD to be equal to 450 pounds, the value of FAB under this condition comes out equal to 454 pounds, which is not possible. So it means our condition of assuming FAD equal to 454 pounds is not correct. Okay, we have to change our condition. So what we do, let's, in spite of taking this, let's go to case number two. So case number one does not hold. So let's make use of case number two. So case number two says, what we can take in case number two is, let's assume another force to be equal to 450 pounds. So let's say case two is let's take some other force to be equal to 450 pound. In case 2, let's say this FAB or FAC is equal to 450 pounds. Okay, let's suppose, let's say FAC is equal to 450 pounds. Okay, let's suppose FAC has attained the maximum value of 450 pounds. So if our FAC is equal to 54 pound, if we are assuming, then from this equation we can obtain the value of, from this equation we can obtain the value of FAB. Therefore, how much will be the value of FAB? The value of FAB comes out equal to minus 0.66 FAC, that's 0.66 into FAC divided by 0.33. So divided by 0.33, it comes out equal to 900 pound. That's again a problem for us. So it means, as we are assuming, let FAC to be equal to 450 pounds, FAC equal to 4, and substituting the value of FAC in this equation, we are obtaining the value of FAB equal to how much? 900 pound, which is again not possible. Okay, so our case 2 is also not a valid case. So let's take case number 3. So case 3 says, let's assume, let's say this FAB is equal, let's say this FAB is equal to 450 pound. Let's say FAB, now FAB is equal to 450 pound. As our FAB, as we are saying FAB is equal to 450 pound, then the value of FAC comes out equal to, therefore, as we are assuming now FAB is 450, from this equation we will obtain the value of FAC. Therefore, FAC will be 0.33 into 450, that is 0.33 into 450 divided by 0.66. That comes out equal to, that's equal to 225 pound. This is will be the value of, this is equal to the value of FAC, which is quite logical for us, which is because this 225 is less than 450 pounds. So assuming that this assuming that FAB is equal to 450 pounds, we obtain the value of FAC, which will be 225 pounds, which is quite logical. Now we have two values. We have the value of FAB 450 pound. We have the value of FAC equal to 225 pound. Therefore, from this equation, we'll obtain the value of W. The value of W will come out to be equal to, this is 0.33. This is 0.33 FAC. FAC is equal to 225 pounds. So this is 225 multiplied with 0.33, that is 74.25. So this will be from this equation, I will write it here, this equation now. So this will be 74.25 will be first term, 74.25 pound plus 0.66 into FAB. FAB is 450. So it is 450 multiplied by 0.66, that is 297 pound. 297 pound, okay, minus W is equal to 0. Therefore, the maximum weight W comes out equal to 297 plus 74.25, which is equal 371.25. Therefore, this 371.25 becomes the maximum weight that we can hang at point A. Therefore, the maximum weight that this crate can have is equal to 371.25, because at this weight, the force in the cable AB will be equal to 450 pounds. If you exceed weight above this, the weight in the cable AB will exceed 450 pounds and the system will fail. Okay, so this is how we'll be solving the rest of the questions. Thank you very much.